Hi guys, greetings from Bulgaria. I'm Anton, and I'm here for our last video from our Selenium 4 video course. Let me share my screen. So, yeah, until now, in this follow-up of the Selenium 4's video course, we talked about first sign-up forms, really great video discussing various test cases and scenarios. If you haven't watched it, check it out. Also, next we discuss various ways how you can verify emails using WebDriver and how you can do even responsive testing and interacting with them in the cloud. In the next video, we talked about this difficult thing, how to handle captchas. And even at the end of the video, we talked about how to do it with some new cognitive AI technologies. It's really interesting, check it out. Then we have discussed how to use cookies to speed up the test execution. Then we discuss various design patterns and techniques, how you can optimize your tests to be more maintainable using different weights in Selenium WebDriver. We talked about adapter design pattern, proxy design pattern, in different configurations of font weights. And then in the last video, we discuss in really comprehensive way all of the various exceptions that you can receive using WebDriver and what you can do to overcome them and how to use them properly. In the last video from this video course, we are going to talk about event listeners, or more or less how you can extend your tests and add additional behavior to them. If you haven't subscribed to the channel yet, please do it now. Hit the ring bell so that you get notified about many new videos that are published each week on the Lambda Test YouTube channel. And also check the blog, Lambda Test blog, because there are many detailed articles there, and you can get the code, whatever. And also, as you know, every time we're working with real-world examples, and you can download everything from the description below. You will find the GitHub repo link. And now, without further ado, let's start talking about Java event listeners in Selenium. Before talking about event listeners, I want to discuss the subject more generally, what actually we need them for. And this is why we will continue the previous topic about exceptions in Selenium and the different exceptions that you are going to receive one way or another during your test execution. There is a whole other video about troubleshooting using new Selenium 4 features. Check it out. It's really awesome, but here we will do something else. We will want to extend, with native tools, the Selenium WebDriver and adding some behavior. And in our case, we'll develop exception analysis service, which will, for example, check when the test failed, whether it happened because of, for example, not the existing web page, internal server error, or, for example, the login wasn't working and then you were redirected to the login page, or something else that you can do, like a further analysis when you receive an exception. And then we will try to use this logic to plug it somewhere. It's not the best practice, everywhere to copy it in your tests. This is why we build libraries and frameworks, etc. We'll discuss some of the patterns that we already checked, like proxy and adapter. I will quickly remind you how to use them, and then we'll first see one of the patterns that actually people use to extend logic. However, as you see in this particular case, it won't be like, it's a little bit complex, and then this is why WebDriver comes with these event listeners, and I'm going to show you how to use them. And not even that, but I will show you how to plug them inside the adapter design pattern. So many things to cover. Let's begin. So first, a quick reminder, during when we talked about handling weights, we discussed two patterns: proxy. What is the proxy? Again, the idea of the proxy is that actually you implement directly the WebDriver interface or any other interface, and basically you can add logic to the original methods. You're perfectly fine because here we use composition. Basically, you have private variables instead of inheritance. And we add additional behavior, like, for example, here, when you find elements or find element, instead of using the native driver find element by selector, here underneath we are using the float weights. However, the interface stays the same, and instead of directly using this interface, you use the web proxy. That's all. In some cases, you want to change the interface itself. For example, instead of having these send keys, you want to name this method type text. You want to remove some of the methods and not expose them, or you want to add additional methods. Then, in this case, we use the adapter design pattern. What was the adapter? We define our own interface, in our case, driver. And here we use, we had this abstract method called start, which is a factory method for initializing in this big switch. Based on this browser, it initializes the driver. And as you can see, we have find elements, wait for Ajax. This is a new method. We change a little bit the signature of the go-to URL. And then here in the driver adapter, this is the actual implementation of this interface. Again, through composition, we have WebDriver and WebDriver wait. In the factory method, we call every time WebDriver manager, we initialize the driver, and more or less here in the override, again, we are doing the same thing. However, we have the same adapter for the element itself. Again, we change the interface of the elements as well. So for an element adapter, we extended the elements, and now they know how they were located. We have this get by, right? And then also we removed some of the methods, and now instead of send keys, we have type text, which combines clear and send keys. For click, we wait for element to be clickable, and then we click it. As we discussed in the last video about exceptions, this is especially important if you don't want to get some of the specific WebDriver exceptions, like non-interactable, etc. However, this is when later on, for example, if you want to plug this logic about the exceptions that we'll write in a minute, or for example, imagine that you want to create logging, or in a minute I will remind you what we did in one of the videos regarding these notifications on top of the screen, then this adapter, maybe it's not the best choice. Why is that? Of course, you can always plug this logic every time and edit all of these methods. However, this is not a good practice, because basically every time when you do that, you will you can cause regression, and many tests might fail, and all of the methods will start doing many things, which is not the best practice, like the single responsibility, right? So this is why we can use the decorator design pattern, which is something like the adapter, but we have additional classes. Basically, we are nesting there is nesting. That's how you basically add additional logic. We have similar interface or abstract class for the driver and for the element, the same like with the adapter. Just the only difference here is that we have one additional class, which is called decorator. This is like the plumbing. This is like the middleware that hooks like your current adapter implementation and then the new addition to it, like for example the logging, and then we can have one more for highlighting or for notifications, right? So basically it's nothing more than just extending the driver abstract class, and through composition we are providing any implementation of this driver abstract class here. And as you can see, there is no additional logic here. We are just calling the same through composition, the same driver, the same type of the method, that's all. So we have the same implementation like with the adapter. It extends the driver, nothing changed. This is similar to the adapter class. However, here the way this works is that we can create additional decorator classes, but instead of deriving from directly the abstract class driver, we are extending the driver decorator and we're providing another driver. This way, again, through like recursively, we are not recursively, but basically we are calling the from the base class the driver, we're calling the same method. However, on top of it, we are adding the additional logic that we want to add to the previous implementations. In this way, we are not editing directly here the web core driver. Instead, we are doing this in separate class. And in order to use that, as you can see, everywhere I put this logging here. And when you want to use these classes, basically, by the way, for in order to hook the decorators for the element, we are doing that directly in the find element instead of directly, for example, here, if this is the decorator or that adapted element. As you can see here, we are decorating inside of walk element, and you can do that again and again, no matter like you're nesting in one another the additional classes. And the way you use them in tests is just basically here. As you can see, we are doing the same. First, we're initializing the logging driver, which has this logging, and then inside of it, we are initializing like the previous adapter, but in this case is this web core driver, the actual implementation with everything. However, as you can see, it's just returning driver. It's basically we're working with the interface. We're like we do normally with regular WebDriver. We're working with the WebDriver interface instead of directly with Chrome driver, right? So the logic here is similar. However, I understand that this can be complicated. This was actually one of the first patterns that I discussed in my design patterns about high quality automated test books. And there is a little bit easier way for simple scenarios. And these are actually the event listeners. This is why we use them. Before before talking about them, I want now to show you another pattern that actually we are going to use to analyze the exceptions. We are going to use chain of responsibility design pattern. And here I created listeners. And if you remember the last video, we created this analyze test exception class, which derives from the base exception native Java class exception. And basically here we have two static methods for formatting properly the exception, adding new lines, this like lines for separating the stack trace and the exception message. And even if the browser is not closed yet, we are printing where this exception occurs on which page, right? So this is basically a prettified exception message. And now another thing that we are going to do the pattern is that we need to create First, how this pattern works. Basically, it works with handlers. Basically, we have one big class called, let's call it exception analyzer. And this exception analyzer, the thing that it will do is that it will hold a static class of exception analyzation handlers. Meaning that, for example, when we start iterating through each handler, these handlers are basically checking and probing the driver, the current browser, the URL, the HTML page, different elements, whatever you put there, and check whether this condition is met. For example, whether the URL is on the login page, or if in the HTML content there is, for example, 404. This means that probably the page doesn't exist. And the first handler that succeeds, we're ending the whole chain. This is why it's called chain of responsibility. So yeah, let me show you how we are going to create these handlers. First, we're going to create one interface for this. And I'm going to call this exception analyzation handler. And inside of it, actually, we will have two things. First, we have detailed issue explanation. This means that when we check that the condition that we mentioned is applicable, is there, then we are going to throw this analyze test exception with the explanation that we set here in some of the implementations of these handlers. For example, we can create one of these handlers called HTML source exception handler. And of course, we are going to implement the interface. You can press Alt Enter and it will generate automatically these methods for you. And this will be actually an abstract class because I want to be able to specify different search phrases in the HTML. So this is why I created two private variables, text to search and source, and then we need to provide the actual page source, which is the HTML of the page. And then what else? We need to override only one of the methods, and this is applicable. Since we are providing the driver, the exception, and any other objects, this means variable number of parameters is basically converted to a list, to array of objects. We first get the page source. We initialize the page source from driver get page source getter, and then we call driver get page source, or maybe you can optimize it like this, whether it contains the text to be searched in the source. And then, for example, we can create one child class, this one, called not found page exception handler. And we're going to extend this abstract class here. In the constructor, we are going to check, is it fine here? Yeah, I missed the constructor. So yeah, basically we need this thing here. And then here we call the super constructor of this abstract class, and we are searching for 404 not found, which means the page has been not found. And then when we need to override the get detailed explanation, this will be like the message that we will provide to our analyzed test exception. and we'll say the page was not found. Maybe we can print the URL, whatever. What else? Maybe we can do one more for checking for error pages, right? Here again, we need to extend from HTML source. As I said, this is why we did it like an abstract class. And we need to call the constructor where we are searching for internal server error, and then we don't have, let's see. Yeah, we need a getter for we need a getter for the page source, and when we go to error page, again we search for internal server error in the HTML, and then the detailed explanation is page failed via internal server error, and this is the source, which can help us to debug and see what's going on. And one more type of analysis that we can do is if we create and if we check the actual URL, right? So we can create, again, another abstract class, URL exception handler. It will be abstract. It will implement, again, the same interface here. And this time, instead of something to search inside the actual HTML, we will provide the text to be searched in the URL. And here we are going to return the actual URL and the part that we are looking into the URL. And we need two other things, of course. The most important one is the isApplicable override, which will check whether this condition is true or not. We are getting the actual URL, and then we're checking whether this part is part of the actual URL. That's all. And if we need to, one example of child class for this is you can create no method account many of these classes, but here we will again extend the URL exception handler. We'll search for login. This means that probably the login failed or there is problem with credentials. And then we are displaying this thing here. Exactly, there is a problem with notification, check what happens during the database restore or whatever, right? And we're providing the actual URL. This can be quite helpful. And then what we do next, we need some imports here. Again, this is static. Now we need logic to add methods to this list. So I added this generic method. Basically, here it's static method. Here we configure the generic parameter, and we say this is our type, the generic type. No matter of these handlers here, we can put it. And I'm saying it needs this is called generic constraint. This means that the type needs to implement or extend this class or interface here. This method is void, and then we are providing actually here we are supplying any of these T-exception normalization handlers, and we are adding them to our static list. And we have another similar static method for removing some of the handlers. And the core logic here is happening inside this method here. It's called analyze. And the thing that we are going to do, again, we are going to for each this list of exception handlers, and we're going to call for each exception handler is applicable and check whether the condition is met or not. If it is, then great, we throw an exception. We are not continuing with the others. This is why it's called chain of responsibility. If the first in the chain cannot do the work, then we move to the next, then to the next, to the next, and until all of them are finished. So I already prepared the code. So we are for reaching this list of exception analyzation handlers. Then we call for each handler is applicable because it's part of the interface. We provide the driver, the exception, and some context. For example, this can be additional parameters. Most of the cases, this will be no. It's fine. If we have driver, then we are providing the actual URL. This means that in the prettified exception, we will have the URL at the bottom. And as we in the last video discussed, sometimes when this happens, we actually, for example, some exceptions happen because the browser is already closed and then you receive WebDriver exception, then it doesn't make sense. You won't be able to get the URL. This is why, in this case, if the driver is already known, then we don't provide the URL. That's all. So before hooking up this, of course, you can use it everywhere inside your code. Basically, the only thing that you need is to call exception analyzer.analyze, provide the driver and the exception, and that's all. Then you move on. Maybe this exception, by the way, most of the cases it can be no as well. I mean, there are certain cases when you want just to check that everything is fine and this is all right. Or you can do that when you receive an assertion exception and then it's fine to start that, and this can help you to analyze your tests. So the question here is, where is the right place to hook this up, right? And as we already saw in the adapter and in a decorator, there isn't any convenient place, right? You can put it like after the click or after some assertions, that's fine. But still, you need to repeat that every time. So a quick reminder from, as I said, there was like the third video from the Selenium 4 course where we discussed some of the new features like the DevTools integration, and then there we have actually this domain called JavaScript where we can pin scripts. What does this mean? You can watch the whole video. I did it from scratch. Now I won't touch what actually we do here with the JavaScript. I'll just explain why we use it and how. But basically this pin method, it will initialize the script every time without the need to run the script every time ourselves manually every time. Because before this was also possible, but this meant that when you navigate to a new page, if you want, for example, to have highlighting or notifications, you needed to execute all of these scripts once again. And now we are hiding all of this complexity and we are moving it to the initialization of the driver, which is great. Like this is possible to, like, I pretty much prefer this approach. So here we have these highlight JavaScript methods that we define every time. Actually, it accepts an element that we found and it will get its original background color and it will highlight. In a minute, I'm going to show you a demo. And then we use the native setTimeout JavaScript function that accepts a callback. And after 1 second, we're going to return to the original background and outline. And the second thing that I use here is that if we don't have jQuery, this is a popular JavaScript library, I initialized it in the page because I wanted to be able to have this another library, jGrow, where we use it for making these pop-up notifications, which can be pretty awesome when troubleshooting tests with some information there. And the way we execute these two methods is actually I define this two Java methods where we use the native JavaScript executor, where we call execute script. As I said, there's an argument here through argument 0. We are providing an element, and this is how we highlight the element. And then with this syntax here, we can print any message to notifications. Let me show you what this means. And after that, I put on purpose here, there's no need for this pause, but I put it just for you on a slow motion to see what's going on. Do you see here the highlight and the notifications, right? This is it. So here we have the fast highlight, and then these notifications where we print something there. And the way I hook this to the current execution is actually I created. Actually, this is the topic for the video. This is the native way of WebDriver, how we can extend it. Here I created this WebDriver listener, and we can override any of the methods. There are many of them, like before any web element call, after, before click, after click, on the navigation. There are many of them. Here I overrided only a few of them. So here, before any web element call, I have access to the element, to the driver, in some of the cases, and this is the place where I'm printing the grow messages, and then after any web element call, I'm highlighting them. And after this is initialized, as you can see here, there is an awesome method that we are going to use. It's called onException, and this is actually the perfect place for us to put our exception analyzer, right? So let me show you how we can do that. And after that, because you cannot imagine to initialize every time that, right? So I'm going to show you how we can do it in a more maintainable way. So let me first show you how we can use first the exception analyzer. First in the setup class, where we download the actual driver needed for Chrome, this is the place where we can add the current exception analyzer that can be run for this particular class. We can improve it, like this is a simplified version of our framework where we have similar feature. So here we call the static class exception analyzer, and then we're adding these analyzers to the static list. Then again, in this override for on exception, we can call like this exception analyzer, analyze driver, and then we can cast this throwable, which is the base class for the exception, and analyze and run it, right? And this way, every time when there is an exception in the driver, we will run our chain of analysis to see what happened, which is perfect. However, again, this is ugly. We want somehow to split the logic, for example, to have one listener for highlighting, one for logging. Right now, we don't have logging. Then we want to have one for the notifications, one for the exception analyzer, another for something else. There are many plugins in practice. So another thing that I added here that it's new is actually this class called log. And like, you're perfectly fine just to, go everywhere, system out, println, and then when you run the test, you will see your messages in the console. And when you run your test in continuous integration, then you're going to see those messages there as well. However, I prefer to create additional wrapper class like a facade, where, as you know, in Java, compared to C#, we don't have actual event listeners, so like native in the language. This is why I simulated the observer design pattern, or simplified version of it. So I created this event listener. Like, it's complex. I'm just going to explain my idea here. It accepts these consumers, whatever. Basically, again, you can do that with just here we have a hash set of consumers, and then we are for eaching them in executing their logic. But this way, basically, in these entry points, like on walked entry, walked info, walk error, you can subscribe, and basically you can create extensions for it. This means that later on, if you don't need only to print it on the console, but also, for example, send it to a database somewhere to the cloud, or we use similar feature for example, BDD logging, or creating dynamic test cases in some internal systems, you can just create extensions for this event listener, and you can hook to them, and then without any change anywhere in the code, you will be able to do that really easy. But this is beyond our topic now. I just wanted to show you that what we need to do in case we want to create such event listener walk WebDriver listener. So I'm going to create here additional class walk WebDriver listener, right? And here I'm going to implement this WebDriver listener interface. And when you press Alt, Enter, actually we need to override the methods. So I already did that for you. Of course, we need to add some imports. And here I use system, as I said, I used system out println, but again, you're free to change it with this additional walk class. Now, when we have this listener, we can create additional one for the highlighting instead of coupling both of them like we did in this huge example that we saw before. So again, let me show you what I did. I implemented again WebDriver listener, and then after we find something, we're calling the highlight element, and I move this private method here where we execute the highlight something. You need to be sure, of course, that you use the pin script or somewhere execute all of the logic for initializing the method. But again, if you haven't used the pin script, then you can use these WebDriver listeners to execute the script. We are going to create one more for the notifications, similar way. So I'm going to create this notification WebDriver listener. Here it is. The whole time I was, wanted to show you like a workable, something real world, because many of them in all other videos or blog posts, they're just these dummy examples and you don't get why you need it. This is why I made it a little bit more complex for you to get why we need it and how we can use it in the real world. Because as I said, we use that in enterprise projects, so you're free to use it. I mean, it's available on GitHub. So here again, I moved basically the grow message method that we execute here, and I plugged it in some points, right? And lastly, I'm going to create one more for the exception analysis WebDriver listener. And what I did here is for on exception method, again, I'm capturing first the message, then the stack trace, it is the right place here to execute the exception handler. And also I moved here, if you remember from our was video about when we talked about handling exceptions in Selenium. When you execute your tests in Lambda test, by default, you won't be able to see the stack trace in the actual exception message that you received here. So first, we need to fail the test using this JavaScript snippet, lambda /status equals to failed. And then if you want the exception message and the stack trace, here we use this approach to from Guava to get the stack trace and convert it to a text. And then we put the message and the stack trace to this array list of strings. And then we provide it here as an argument to this lambda test /exceptions, lambda /exceptions. And this way it will be populated there. And when the test in the platform there is failed, you will be able to see the actual message and the stack trace. And this is really easy how you can plug it in the WebDriver listener. And again, as I said, this is the right place to plug the exception analysis. When you receive this exception, here on top of this other exception that you received, it will be great to run the exception analysis and maybe here provide the prettified exception that we already discussed. And now, when we have all these listeners, where is the right place to hook everything up? Well, I think I prefer the adapter on, instead of decorator. So in the driver interface here, I will add one more method called get WebDriver listener, even listeners in plural. And then in the driver adapter, we will define and override this method here. And I just need all imports. So basically, we created in this method, we initialize a list of, here we provide actually the interface, and we add the 4 different implementations of it. Because until now I showed you actually how, if we return to our example here, the simplified one, when we initialize the listener, we need to call new event variant decorator, provide the listener, and then call .decorate driver. And actually this is returning again the same interface, the WebDriver, but we're again similar to how we use the decorator, because it's doing the same thing but under the hood without this complexity of having all these additional classes. However, here we added only one listener. How do you add more than one? Because in our case we have 4. Well, in the driver adapter, the thing that we can do, the right place is here. So here we need to do something to initialize of the listeners. So first, I call the method that we already defined to get all of the listeners, and then we can recursively use Stream API to initialize them, or you can use standard, standard for each. It's up to you. But basically, each time recursively, we are initializing the current WebDriver instance with the new decorated one. Right? We are iterating through all of the listeners, mentioning every time new event decorator from the current listener, and we're nesting them like we did with the decorator, but no matter. Basically, if you add here 4 more, basically you're going to add them immediately here, which is really great. Like if you need to add more, you just do it here. In more sophisticated frameworks, we usually use inversion of control containers, and this is actually in our production framework for enterprise projects. This is the way we do it. We don't initialize them here, but I basically add them to the inversion of control container, and then here we automatically initialize everything. And this way we a while people using the framework without modifying the core of the framework to add these listeners, which is pretty awesome, right? So I think this was most of what I wanted to show you. Of course, today's video was a little bit more complex, but this is the topic. When we talk about extending, you need to get the whole picture, and I wanted to present to you again something that it's more close to the real world. This was our last video from this video course. Thank you for watching. Please, if you have any questions, put them in the comments below. Please suggest what you want to see next in this great video channel of Lambda Test. Also, don't forget to check the blog. It was an honor for me to teach you about these concepts. And of course, don't forget to get your free certification about Selenium JUnit and many more. Thank you for watching, and I hope that we will see you soon. Bye. Take care.